Good day, friends. Right now, let's try to solve this problem. A smooth surface inclined at an angle alpha ends at the edge of a ditch. The ditch has width 24 centimeters and depth 195 centimeters. A small ball slides along the surface at the edge of the slope. The speed of the ball is 12 meters per second. How many times will the ball strike the vertical walls of the ditch before it reaches the bottom? It is given then that tangent alpha is 5 divided by 12. The walls of the ditch are vertical. So what we have here is something like this. This is the image of our object. So at the very beginning, it comes from this position to here, and then it falls at a certain angle, which is alpha. And when it falls, definitely it will hit the walls, because walls are not that distant from each other, and it will hit walls several times, maybe just one time, we don't know, but we have to prove it. So it's going to fall something like this, and it really does not matter where it will end up, if it's here, 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 or here, here. The most important thing is not where it will appear, is that where we will, how many times will our ball touch the walls, right? Okay. So what we know about this, we know that this velocity has some vertical components, which vertical and horizontal components like this and this. However, if I just zoom it out, it would be the same thing as this angle alpha, right? So it's something like this and this. And we definitely know that this part is v cosine alpha and this part is v sine alpha, because opposite is sine and adjacent is cosine. Yeah, right? Good. So let me take this like here. Yeah, let me just put something like this, and this. Yeah. So vertical one would be v sine alpha, and horizontal one would be v cosine alpha. Okay. What else? What else? Yeah. Let me bring back this velocity. It would not be much of a deal. Yeah. Okay. So what else do we have here? This is really important because, as you can see, tangent alpha is known, and it means that if we know tangent alpha, it means that we also know sine alpha and cosine alpha and anything else. Because basically, if we draw some kind of a triangle, we know that, yeah, let me just take it a little bit, probably here and here, so it was a little bit more perfect. So if we have here an angle alpha, we know that tangent is opposite divided by adjacent. So it's a relation between this opposite side and this adjacent side. And we also have here hypotenuse, but tangent gives us no information about hypotenuse. But in fact it does, because if we have here something like 5 divided by 12, yeah, 5 divided by 12, and if we apply those numbers here, 5 is opposite, it is here, and 12 is here, we can apply here Pythagorean theorem, which is a squared plus b squared equals c squared. So the same thing comes here, 5 squared plus 12 squared equals c squared, and it will be just 169 equals c squared, and c would be just 13, perfectly 13. This side would be 13. And we know that other things like sine and cosine are just opposite divided by hypotenuse, or adjacent divided by hypotenuse. Okay, so opposite divided by hypotenuse. Here we can see that opposite is 5, hypotenuse is 13. That's how we get our sine alpha, which is 5 divided by 13, right? And about cosine alpha, adjacent is 12, hypotenuse is 13, so it's just 12 divided by 13. So that's how we have our sine alpha. It is this one, and cosine alpha is this one. Yeah, good. So if we have in our answer at the end sine alpha and cosine alpha, that's not a problem. We can treat this problem with two methods. Yeah, a little bit harder and longer one, which is counting the number of these ends. Yeah, the way that we really need to, or we can find easier way. We just can continue this problem to this ball falling in some distant area. Yeah, just imagine that this wall is not there, and we can just divide this entire length that we will have with this small distance, and that's how we get the answer. How many times? Because each one of those d's are the number of the bouncings, in fact. However, let's choose a little bit longer path, because it will give us some kind of new ideas probably, or maybe treat this problem just the way it is. Okay, so what can we do? No matter how many times it will bounce off, the formula will be the same. Why? Because it's just number of bouncings. This would be the n, and d is not changing. So horizontally, what does it do? It covers several number of d distances, right? So that's how in a horizontal axis we can write this kind of equation, like nd, which means that number of bouncings. Oh, these things are not important. Yeah, number of bouncings and the distance which is covered will be equal to. Yeah, we have this formula, which is just basically delta x equals v initial t plus at squared divided by 2. Yeah, and the same thing we can do here. Delta x would be number of distances, this d covered, and our v initial would be this, our horizontal, v cosine alpha. V cosine alpha. T would be something unknown, and here we have, horizontally, we have any force acting on our object. However, what we need to know is this n. right? Yeah, we have no this acceleration because we have no forces, and we know that F equals ma. If there is no a, there is no force. If there is no force, there is no acceleration, right? And we're not told anything about air resistance or anything, okay? So if we just write down here the formula of n, it would be just v cosine alpha t divided by d. Yeah, good. This would be our very important equation for n number of bouncings. However, we don't know about t. We have no information about t. That's why let's write down here the equation for y-axis. It would be height. Yeah, this our delta y would be the height. However, it would be negative y because our final x would be, how our final y would be at the bottom. It's just the height 0. This would be y final. Y initial is, instead, it is h. It is our y initial. So our y final minus y initial would be just 0 minus h, which is just minus h. Okay, this is really important part to understand. Yeah, let me just take this off. Yeah, it would be like this. So y-axis, yeah, delta y would be, as I've said before, minus h equals v initial, but vertical one, which is v sine alpha t, and also we've got acceleration, but it's gravitational acceleration, and it is downward, and v sine alpha is also downward. As you can see here, it is directed downward, and it is a vector quantity, velocity. That's why we need to put minus, because its direction is very important. And this thing is okay because v cosine alpha is going to the right, which is positive value, and there is no problem with this part. Yeah, and here we can see that this is just minus gt squared divided by 2, or write it something like 1 divided by 2 gt squared. It's the same thing, but yeah. So yeah, we can see that all of these things are minus. That's why we can multiply all of them to minus 1, and all of these things will become just plus. Yeah, but in fact, I want to do something else. I want to collect all of them to one side, and let's collect them to this left side. This thing and this thing, let's collect them somewhere here, and we will have something like this. Yeah, let's write it 1 divided by 2 gt squared. It's this thing exactly, and it will be positive because in that side it was negative, right? The same thing happens to our v sine alpha t. It will become positive, v sine alpha t, and this thing is going to still be minus h equals 0 because all of the factors which were on the right side just left that side. That's how it is 0. But what you can see is something very interesting. We can find t here, but it is what? This is quadratic equation. This is ax squared plus bx plus c equals 0, isn't it? Because as you can see here, our x squared is t squared, x is t, and our 1 divided by g is 1 divided by 2g is a, v sine alpha is b, and minus h is our c. Yeah, minus h, not just h. We need to take this into account because this minus will play its role. Yeah, minus h would be c. Yeah, let me show it something like this. This is this one, this is this one, and this is this one. Okay, and we can apply here a quadratic formula, which is if we want to, oops, I'm sorry. If we want to apply here, if we want to find here x, we of course use quadratic formula, which is minus b plus minus square root b squared minus 4ac all divided by 2a. Okay, but I will guess that we don't need minus value because this thing's gonna go negative. Yeah, this thing is going to go negative, of course. That's why we don't apply our minus, just plus. Okay, if we do the same thing for t, it's going to be what? Let me open this up. T is going to be this huge. Okay, our minus b would be our minus v sine alpha. Okay, let's write it here. Minus v sine alpha. Plus. Okay, it will be even longer, as I see. Yeah, huge square root, and b squared would be just v squared sine alpha squared, v squared sine squared alpha minus 4ac. We have here minus 4a is our 1 divided by 2g, and c is negative h. Let's write it down. Yeah, let's write it down. Why not? 1 divided by 2g, and here we have minus h, and 2a would be just 2 multiplied 1 divided by 2g. 2 multiplied 1 divided by 2g. And what is interesting, this is going to go away. 2 and 4 and 2 is going to go away. This would be just 2. And what else? This minus and this minus and this minus is going to become plus. And that's how we get something like this. Minus v sine alpha. Still v sine alpha plus this thing. V squared sine squared alpha plus, because we have minus and minus. Yeah. And 2gh. 2gh. Yeah. This is the thing. And below we have just g, because two twos just annihilated each other. That's how we have our times formula, which is this one. Yeah, this is our time. And as you can see here, we have this formula, and we can just put it here. Our final result would be something like let's write it here. N equals v cosine alpha divided by t, v cosine alpha t, v cosine alpha divided by d, I'm sorry, d here. And instead of t, yeah, we can write it something like this, t, yeah, why not? It's the same thing. But instead of t, we put this long thing. So instead, let me bring all this thing here instead of t. Yeah, I will put it instead of t, and I will have something like this. Yeah, and let me bring this g here and change nothing, just the basic maths, and you will have something like this. This is in brackets, of course. Yeah, I guess this is our final result. Yeah, and this is the number of bouncings that we will get. V cosine alpha divided by dg minus v sine alpha plus square root v squared sine alpha squared plus 2gh. So let's see if we have all the factors that we are given with. Velocity, yes, we are given. It is set at the very beginning that we have velocity, and we have here d, we have here h, and tangent alpha. And if tangent alpha is known, that we have proved that we can find sine alpha and cosine alpha. So if in the answer we have cosine alpha and sine alpha, that's not a problem. We know this thing, yeah. So let me do it like this. We know v, we know alpha, cosine alpha, we know d, we know g is constant, v is known, sine alpha is known, v squared sine alpha is known, 2, and gh is also known. Yeah, good. So this thing can be our answer. Yeah, this is valid, and you can put these things into its places and have some answer, but I will not, because the main thing, the physics part, is done, and this is our answer. If you have any questions, you can write me privately, and thanks for your attention. Goodbye.